Hey guys, welcome back. This is your third and final lesson for this week and for the school year. You've made it to the end. All right, so what we are looking at today is 9.6. So for number one, we want to find the distance between point A and each of the points on the number line. So A and F. So A, so we go 1, 2, 3, 4, 5, 6, 7. So A to F is 7. A to C is 1, 2, 3, 4. A to G is 2 less than that, so it's 2. A to B is just 1. A to D is 1, 2, 3, 4. And A to E is 4, 5, 6. So there are all our distances from point A for each of those other points. So now for number 2, what is the total of all the distances from point A that you found in exercise number 1? So we're going to take all 6 of these values and we're going to add them together to find the total. So 7 plus 4 is 11, plus 2 is 13, plus 1 is 14, plus 4 is 18, plus 6 is 24. So the total is 24. All right, for number 3, find the average of the distances that you found in exercise 1. So what we're looking at here is basically we're taking 2 and 3 and separating apart, finding the mean of a set of data. So we're going to take the total distances, which is 24, and divide it by how many different points we had, which was 6. So 24 divided by 6 is 4. So our answer is 4. So the average or mean of the data is 4. All right, so 4 and 5, you're going to take and use what we did in 3 to find or identify any points that are exactly the mean or average from A. Then for 6, you're going to do it all over again, but you're going to be using point D this time, point D, okay? All right, our next section is looking at scatter plots and lines of best fit or trend lines, and trend lines is your key word for this lesson. Now, we have a table here. This is giving us a set of data. So you're going to have 5 points on your scatter plot, only 5. So each row is an ordered pair. So you're going to have the point 60, 65, the point 53, 59. The English scores will be down here. The history will be your y-axis. So you'll draw the axes out, plot your points, and then questions 12 and 13 you'll answer about that. So it's dealing with positive or negative correlation. Think of it in terms of slope. Would it have a positive slope or would it have a negative slope? And then for 13, does it have a strong or weak correlation? So strong correlation means that the points are very close together and they essentially form a line, whereas weak correlation means they're kind of all over the place. So it's hard to really tell whether it's positive or negative per se when it's a weak correlation. All right, for number 14, which graph below shows the best model for the data and will create the best prediction? Explain why. So looking at these, we've got these trend lines, and we want to determine which one best represents the data that we have. Well, if we look at this first one, there's 2 points on the line, so that's pretty good. But the rest of our points aren't on the line, and this one over here is pretty far away from the actual line. This one's a little ways. This one's fairly close. This one's a good distance. So not necessarily the best line, especially if we're trying to make a prediction for after this point. It might actually be here, but it's saying it's going to be way up here. That's a pretty big difference. So it's got too steep of a slope for us. This one here isn't touching a single point, so not a single point is on this line. These two are kind of close, but all the rest of them are significantly above the line. So once again, this is not a good representation of this data. Now, this line here, we do have 1 point that is on the line, but the rest of our points are super close to the line. So they're about equal distance from either side of the line on each side. Now, obviously, there's 3 points on this side and only 2 points on this side, but they're all relatively close to this line. So C is our answer because they are all close to the line. So the closer the points are to the line, the more accurate the trend line is. That's your goal there. Now, in this case, it was a linear model that represented it. That may not be the case in 15 and 16. It just depends on the data, what kind of model best represents that data. So it could be linear, it could be exponential. So you might have a curve representing it. That's perfectly acceptable. Don't assume it has to be a perfectly straight line. All right, and this last section, we are looking at arithmetic and geometric sequences and writing the explicit function rule for each. So we've done this before. We did this all the way back at the beginning of the year, so we're doing a bit of a review here. So remember, common difference goes with arithmetic, common ratio goes with geometric, and I'm going to switch over to my camera so that you guys can see as we work through these. So for 17, it says f of 2 equals 7, and the common difference is 3. So that means this one is arithmetic. So we're going to use point slope form to take and solve. So we start with y equals our slope, or common difference, which is 3, times, parentheses, x minus our x value, which is this 2 here, close parentheses, plus our y value, which was 7. So we end up with that. Now we want to distribute the 3 to both parts. So we're going to have y equals 3x minus 6 plus 7. We combine like terms, so we have y equals 3x plus 1. There's our answer. All right, now the next one, number 19, we have h of 6 equals 3, and the common ratio is -3. So because it's a ratio, that means it's geometric. So remember, with geometric sequences, we always start with the first number given to us. So that's the 3. And then what goes in the parentheses is our common ratio. So in this case, the -1/3. And then we take it to the power of n minus 6. Now this 6 comes from right here. If that would have been a 10, we would have said to the n minus 10. If it would have been a -5, we would have said to the n plus 5. So it just depends on what your x value is, what your exponent is going to look like here. But this number here comes from what this equals. The number in the parentheses is always your common ratio, and your exponent always depends on what's inside the parentheses originally. Okay? So these are what you're going to do for the arithmetic sequences, so the ones that say common difference. This is what you're going to do for the ones that say common ratio, the geometric ones. Alrighty? A reminder, your keyword for this lesson is trend lines. Have a wonderful week and happy mathing, and I hope you guys have a wonderful summer. It's been a joy having you guys this year. Bye.